Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge on the challenge number 88 called the merge sorted array. And for this particular challenge, we are given two integer arrays, which is nums1 and nums2, sorted in non-decreasing order, and two integers, which is m and n, representing the number of elements in nums1 and nums2 respectively. So we have the function merge that takes four parameters. The first one, which is the nums1 in the form of array of numbers, and the second one, which is the m, and it is denoting the number of elements inside the nums1. And we have the nums2, which is the array of elements, and the n, which is denoting the number of valid values inside the nums2 array. Let's say nums2 array, not nums2 but nums1 array has 6 elements within the length of 6 elements or 6 values, which is 1, 2, 3, 0, 0 and 0. But then the m is only denoting that the value is only contains 3. It's because the 0 after that is considered, it's not counted within this m parameter. And the purpose of all of the zeros after the last value of the nums1 array is a placeholder, so it makes sure that the elements inside the nums2 can fit inside the nums1 array size. And this is a vacant position to be placed for the 2, 5 and 6 respectively inside the nums1 array. And the final sorted array should not be returned by the function, but instead be stored inside the array nums1. Hence the function, which in a form of void, it is not supposed to return anything like returning a number or returning an array or returning anything. To accommodate this, nums1 has a length of m plus n, which is the combination of the m parameter plus the n parameter, where the first m elements denote the elements that should be merged and the last n elements are set to 0 and should be ignored. Nums2 has the length of n, like I explained earlier. It's about the m and n denoting the real numbers of both nums1 and nums2. If there is something after the highest value of the highest element of the nums1, then there are zeros, then it will be replaced by the nums2 elements. And we are using the TypeScript as our language. If you want to use something else other than TypeScript, then go ahead and encourage you to do so. And for this example number 1, right here we have the nums1, which is 1, 2, 3, 0, 0, 0, and the size of it, which is 3, which is the valid values or the valid elements, and the nums2, which is 2, 5 and 6, and the valid elements, which is the n, is there are 3 elements that is considered of valid elements. And the output is 1, 2, 2, 3, 5, 7. And the explanation that says the array we are merging are 1, 2, 3 and 2, 5 and 6. The result of the merge is 1, 2, 2, 3, 5 and 6, with the underlying elements coming from the nums1, and 1, 2 and 3 right here respectively is coming from the nums1 array. And if you notice something, that the nums1 has the sorted elements inside it, but especially for the vacant elements is only filled by zeros are placed at the last elements of the nums1 or the trailing elements of the nums1. And also the same thing with the nums2, is already sorted and you don't have to worry about that. Then the output should be also be sorted. If we happen to just insert the 2, 5 and 6 into the nums1 array and mutate the nums1 array, and it will be 1, 2, 3, 2, 5 and 6, which is not sorted. And for the example number 2 right here, we have the nums1, which is has only one element, which is element 1, and the value is still m equals to 1 because 1 is a valid value and it's not a placeholder of zeros. And the nums2, which is the only empty array, but the n is equals to 0, and the output should be nums1 as it is and not mutated at all, is because the array that we are merging are 1 and empty array, so that the empty array will be ignored. And we can add a check if the nums2 has the empty array, then we can just leave it as is and return nothing using the return statement. And the result of the merge is array of nums1 untouched. Okay, what about the example 3, which is the other way around? Nums1 has the placeholder value of 0 and the m is 0, not 1, is because the 0 right here is supposed to be replaced by the elements inside the nums2 array, which is 1 right here. Why? Is because the nums1 array has only the 0 values and not other value like -1 or minus something lower than 0, and there is no +1 or anything higher than that prior to the element 0 right here. And this makes that the element of 0 is the only one standing inside the nums1 array, so it will be replaced by the nums2 elements of the array, and the nums1 will becomes the nums2 array. And the explanation that the arrays we are merging are empty array and array of 1 from the nums2. Note that because the m is equals to 0, which is empty array, supposed to be empty array, there are no elements in nums1, and the 0 is only there to insert the merge result can fit in nums1. And the follow-up question, that can we come up with an algorithm that runs with the complexity of the big O notation of m plus n complexity time? And we have several hints right here. We can easily solve this problem if we simply think about 2 elements at a time rather than 2 arrays. We know that each of the individual arrays is sorted. What we don't know is how they will intertwine. Can we take a local decision and arrive at an optimal solution? And for the hint number 2 right here, we have, if we simply consider 1 element each at a time from the 2 arrays and make a decision and proceed accordingly, we will arrive at the optimal solution, which is the m plus n big O complexity time. Okay, so let's solve this out. The first approach, I have two approaches. The first one, which is using the built-in sort method from the JavaScript or TypeScript. But if you're trying to solve this with something else other than JavaScript or TypeScript, then you have to figure it out by searching through the documentation of the respective language. Okay, so let me show you the first approach, which is a fairly simple approach by creating a for loop. Is in the for loop, check if the let I is equals to 0, and as long as I is below the nums1, not nums1.length, but yeah, nums1.length. Let's test this out, and then I++, and we are iterating over the array 1, not the array 1 but the array 2 instead, because we are trying to insert the array 2 inside the array 1 of the last element and insert it with the using the array 2 or the nums2. And since we are iterating over the nums2 array, then we need to insert the arrays in the nums1 nums1 of the nums1.length, taking the length of the nums1 and then -1 because we are working with array, of course. Then we are pointing to the last elements of the nums1, which is the 0 right here, and then using the -i. Why is it supposed to be -i? Is because we are trying to iterate over the array right here. Let's say we are iterating like 1, 2, 3 and 0, 0, 0. We happen to insert the both 2, 5 and 6 respectively, so that way we are pointing to the nums1 using the nums1.length, the length of the array, and then -1, which is pointing to the -1 will make this point to the last element of the nums1 array, and then using the -i, and then equals using the equals nums2 using the nums2.length, and then -1 is pointing to the last element of the second array, which is the nums2 array, and then -i, and that way we are pointing to the last element on each iteration. That way we are replacing the nums1 of the specified index with the elements of the nums2 with the specified index, which is 6 right here, and that way we are replacing the 0 with the 6. And for the next iteration of the for loop, right, I equals to 0 nums2.length, and that way we are moving to the second iteration, which is I plus I equals to 1. And since I equals to 1, then of course we are pointing to the last element, and then minus I, which is minus 1. I already said earlier because the I is already equals to 1. And also the same thing points to the 5 right here. See nums2 dot length and minus 1, and then minus 1 again. That way we are pointing 5, and we assign 5 into the array, nums1 array. And also the same thing with the 2 array, and the for loop will stops, and there will be no for loop for the next operation of the 3, 2 and 1 respectively, because we are only iterating over the nums2 dot length. And don't forget, use the nums2 dot length minus 1, not minus 1, but just nums2 dot length, just like that, is because as long as I is below the nums2 dot length, since length is 3 equals to 3, then if I is equals to 2, which is the last index of the array, then it should still runs. And if it's I already 3, then the for loop will stops and the for loop will not execute. We already handled this by using the less than operator. Okay, for the next one, we can simply use the nums1 and then sort. We can sort this and just run the code. And we have accepted test cases, and so let's submit this code to see if it works. Simply control enter, and we got the wrong answer, that it is started from the minus 10, and then minus 9, but then the output is starting from minus 1, and then minus 10. Why the sorting is returning this kind of messy output instead of minus 10, and then minus 9 respectively, just like we are counting a number as usual? Is because the sort method is only sorting the character instead of the literal value of the integer from the negative sign. It's comparing only the negative with the negative, and if it is the same, then go ahead, then 1 with the 1, and then 0, since 0 is higher than the white space, then the sort will place this after the white space, which is the empty space right here, and we are inserting 0 after the 1 instead of we are using the arithmetic sequence of the integer like we are supposed to solve. And it's because we haven't include the comparison parameter, like comparing both parameters using the a and b, and then using the arrow function, and we can just implicitly return a minus b, and that way we are comparing both integers instead of comparing both character code. So let's run this again, and the sort method will treat this as the integer instead of just a character. And we have this runtime, which is more effective, and just sort this sort code, sort challenge, I suppose. But then it is easier because we are just using the sort method instead of putting an effort into solving this code. And because the sort method from the default JavaScript or TypeScript language is using, I believe we are using the quick sort or merge sort algorithm, and that takes the big O notation of the O and then n logarithmic time of n, instead of, which is slower than the O with the m plus n. And the follow-up questions, can we come up with an algorithm that runs in big O notation of m plus n instead of n logarithmic time of n? Okay, so for the second approach, I'm going to utilize the second parameter and the last parameter of the m and n respectively. So let's declare the I, j, and k to point out using the 3 pointers approach, using the let I equals to m minus 1, and also let j equals to n minus 1. Why we are using the minus 1 with the parameter of with the variable of I and j respectively is because that the m contains the true value or the non-placeholder value of the three elements. Let's say we have three elements of the nums1, then the m is equals to 3, and the trailing zeros after the max elements is not being counted, and that way we are using the m-1 to determine, to point the last index of the true elements of the nums1, and we are pointing to the 3 right here. And also for the second pointer, we are using the nums2, and we are going to utilize the j variable to the nums2 array as the pointer of the current index of the nums2 array. And we are pointing to the 6 right here. It's because the n is equals to 3, and we have 3 valid values of the nums2 array, and since n-1 just like on the m-1, and we are pointing to the 6 right here, which is the last element of the nums2 array. And the last thing is the third pointer, which is the let k equals to m plus n and then -1. That way we are pointing both m and n, which is points to the last element of the whole array of the nums1 to be replaced. Let's say we have 0 0 0 right here, and we are going to replace this with the 2 5 and 6 respectively. Then we are using the pointer k as the last index of the nums1 array, and the pointer k will point right here, and pointer I points right here, and the pointer j points right here. Okay, so let's use the while loop as long as the j or the j right here, j pointer is equals to 0 or more than 0, and then we execute our code every time. So that way we are applying both insertion inside the nums1 and comparison between the nums1 and nums2 array, and then the sorting method of the nums1 and nums2 without using the sort method of the built-in function of the JavaScript and TypeScript. So that is why we are using the while loop right here with the j higher or equals to 0. And the next one, we need to add a boundary to check if the I pointer is not pointing other than the last element of the first element right here, which is the after the index 0, which is the -1, and we need to prevent that from happening. Why? It's because we are trying to point out from the first approach. If you still remember that the first approach that we are using the 1 2 3 and then 0 0 0, and the next one, which is the 2 5 and 6, and the k is pointing to the last element, which is right here. And let me use of caret sign. In the caret sign, point I pointer, and the caret sign of the k pointer, and then the caret sign of the j pointer. And we can use the if check from the first approach. We are using the reverse method from the back to the front. We are iterating from the back and then up all the way up to the front of the array. Then we need to handle this to prevent this from overlapping the boundary of the nums1 array. Like this, the sequence will be like this: the first iteration, and then the next iteration, and then the next iteration, that way. And also the same thing with the j, and then the next iteration will be like this, and then the next iteration to check if 5 is, let me visualize this for a moment. We can add a check for the I and j to check which one is higher from the pointer I and j. Since j is higher, then we will insert the j at the end of the array, which is the k right here, and then the 0 will be replaced by the j, which is 6 right here. And that way we are moving j to the next iteration, but the I still placed right here, and the k will move because the k already inserted with the value of 6. And the next one, we need to compare 5 with 3. Since 5 is still higher than 3, then we will insert the 5 into the k pointer, and the k pointer will move up to the next iteration, and the j will also move out to the next iteration, and we compare both 3 and 2. Since 3 is higher, then we will move the 3 using the pointer I right here, assign this to the pointer k, which is 3, and that way we are moving the I pointer by 1, and the k stay still, but also moves to the next one because the 3 already assigned from the operation of the k and I, and also j stays here, and then we need to compare both j and I again. Since j and I are the same, then of course we are assigning the k with either I or j, you name it, because they are both equal. Then we are assigning this k, and we move the j by 1, and since we are already moving the j by 1, then the j is -1, and since the j is -1, then of course the while loop will stops, and we return the result, which is the 1, 2, 2, 3, 5, and 6. If you notice, that is the same with the example 1 right here, with the output right here. So let's practice this using the if the I is higher or equals than 0, and then n using the n sign, and operator if the nums1 of the I pointer is higher than the nums2 of the j pointer. If it is, then we need to assign the nums I of the k, remember, of the k, and then using the nums I using the I, nums1 of the I index, and then we are moving the I -1s, and also on the other way around to check using the else check. If it is the other way around, which is the j, if the j is higher, then we need to assign the nums1 of the k, not the j but the k, equals to the nums1 equals to the nums2 of the j. Remember, it's supposed to be nums2 because we are assigning nums2 into the nums1 array, and we use the j -. And how do we move the k as after we assign the nums1k and the nums1k both if and else check? We can simply place this outside of the if else check. And for the next check, let's see, for the example number 3 right here, we have nums1 equals to 0, and let's remove the pointer for now, and the nums2 we have the value of 1, and then since the I is equals to 0, because from the m-1, and then the I will points out to the -1. Let me move this out. So since the -1 is non-existent, then we can just assign the -1, and we are pointing outside of the 0 right here, and the k is the m is, because m is 0 plus the n equals to 1, and we have 1, and then -1 is k is pointing to the index 0, and k is pointing to the index 0, and the j is supposed to be pointing to the n equals to 1. Since n equals to 1, then n -1 is equals to 0, and then j is pointing to the 0, and since I already points to the -1, then we can just an if check. Since if right here is not applicable because it is already behind the 0, already -1, then it's not applicable, then the else check will triggers the nums1 of the k. Since the k is pointing to the index 0, then it will be assigned with the nums2 with the j, and we are assigning the j into the -1, not the -1 but the nums1, and the j will moves forward by 1, and the k will also moves forward by 1, and both I and k is pointing to the -1. Since the j is already pointing to the -1, then the while loop will stops, and we return the result right away. So let's run the code to see if it works by using the Control Enter, and we have the similar runtime, but for this challenge and just trying to point it out to you so we can study together and we can educate ourselves together from this kind of video. I hope that helps. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section. Or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day and I will see you in the next video. Goodbye.